All right, so let's do an example over the material we just covered. So first off, let's start by reading this problem, and then we'll go through and highlight keywords that might be important. So this problem tells us we have an object whose weight is 100 pound force. It's going to experience a decrease in kinetic energy of 500 foot-pound force and an increase in potential energy of 1500 foot-pound force. Our initial velocity is given as 40 feet per second, and initial height is given as 30 feet. Okay, we want to find the velocity at the second point and the height at the second point. That will cause the decrease in energy or increase stated. All right, so since we have kinetic energy and potential energy given to us, we're probably going to need to use our two equations for those things. So let's write those down. So we've got 1/2 m v2 squared minus v1 squared. And then for potential energy, we're going to have the weight mg times h2 minus h1. So now we've got our equations. Now let's go through here and let's make sure we've noticed all the details in the problem. So first we're given weight. We have a decrease in kinetic energy, gives you the amount. We have an increase in potential energy, there's the amount, and then you've got your initial velocity and your initial height. Okay, so your initial velocity, which is v1, is going to be 40 feet per second, and then your initial height, which is h1, is given as 30 feet. All right, so now we know that. Now what we want to do is we want to find velocity and then height. So to get velocity, we're going to use this kinetic energy equation. To get our height, we'll use the potential energy equation. So if we notice both of these, or this kinetic energy equation, it needs mass. Okay, we don't have mass given to us. We were given weight. Remember, weight is not mass. Weight is m times g. So m times g is 100 pound force. Okay, so first, in order to use this kinetic energy equation, let's find mass. So this will be for part A. So to get that, we're going to have 100 pound force. And if you look at this, weight is mass times gravity. Okay, so you might think you'll just take this weight, divide by gravity. Remember, gravity in the English system is 32.2 foot-pounds, not foot-pounds, 32.2 feet per second squared. All right, now if you look at your units, there is not a unit of mass there. Okay, so that's where you're going to use that conversion I talked about when we did the units. So just to show you where it comes from, we're going to multiply this by 32 pounds foot per second squared over pound force. Okay. So this is why students don't like the English units, because they have all these weird conversion things going on. Now if you look, pound force cancels out, feet per second squared cancels out, you're left with pounds, which is a unit of mass, which is what we want. Okay. So essentially, once you cancel those two out, you end up with 100 pounds. All right, so your 100 pound force is the same as 100 pounds for mass. Okay, a little weird, but that's how it works out. So now we have our mass. Now let's look at our kinetic energy. So we were told we had a decrease in kinetic energy. So that means it was negative, because it's a decrease. And the magnitude was 500 foot-pound force. All right, so like that. Now with that information, what we can do is we can take this equation and let's solve this equation for V2, because that's what we're wanting to find. Okay, so V2, once you solve for that, you're going to get your change in kinetic energy over 1/2 m plus v1 squared. And then you need to take the square root of that whole thing. So now we need to just plug in our numbers. Right? So we're going to have negative 500 foot-pound force over 1/2 100 pounds. And here we are again. We're going to have to do that conversion again. So 32.2 pound foot per second squared per pound force. And we're having to do this because we want units of velocity. So units of velocity in the English system would be feet per second. So we can't just leave these pound force and pounds in here. So let's get rid of those. So notice those go away now. And then let's finish it out with V1 squared. So we'll have plus 40 feet per second squared, and then close that bracket, and then we need to do the square root. Okay. Now notice your units here, you got feet squared, second squared, and then here you'll have feet squared, second squared. All right, and then when you take the square root of all that, it ends up being feet per second, which is exactly what we want. Okay, so now just do the math in here, take the square root, and you'll get that your final velocity is 35.749 feet per second. All right. Now for our second part, we're going to look at our potential energy equation. So that's this one right here. So it's essentially the weight times the change in height. And we were told we had an increase in potential energy. So here we're going to have a change of 1,500 foot-pound force. That's going to equal mg times h2 minus the 30 feet, because this was the initial height that was given. Now we know what mg is. That was given. That's weight, right? So that was 100 pound force. So let's go ahead and plug that in. And then we're going to multiply by h2 minus 30 feet. Now that we've got this, we can reorganize this equation to solve for h2. So we're going to have 1,500 feet-pound force. Let's divide by the 100. And then move this 30 over. Like that. And then that'll equal h2. So h2 is what we want. So let's check the units out, because that's always a good way to see if you're doing it right. Pound force, those cancel. You're left with feet and then feet. So you can add those units. So it's perfect. So now dividing this, that'll give you 15 plus 30. So h2 is going to be 45 feet. Okay. So there you go. So that's kind of a review of kinetic and potential energy. Hopefully you've seen that before, and it's nothing really new, but hopefully at least that gives you a reminder of how those equations work. All right, guys, I will see y'all in the next video.